What I'll be talking about is some of the perspectives that I have in terms of what we are facing in Nepal and what risks, we are addressing or we are trying to address it, and what will be the way forward in future to make our water infrastructure more safer. Water infrastructures in Nepal, in my opinion, are facing risk at two stages. One is even before the construction. You might be wondering what kind of risks the infrastructure might have before the construction. Many storage projects or large scale hydropower projects, primarily identified in Nepal for many decades, hasn't been realized yet. For example, Pancheshwar hydropower project we have heard for I think I would say decades. There are several other projects. The reason the risk is geopolitical risks. You might be wondering. I don't want to elaborate further. So they haven't been constructed so far, even before they start of construction due to geopolitical risks. The second stage is after construction that we were talking earlier. Also, Alex showed many examples. What kind of risks water infrastructures, dams can have during its lifetime, and sometimes even cannot go until the end of its life because of many failures, mechanism, and others. So that's the second risk we are facing. And the second point I would like to make is dams. Experience of Nepal in terms of dam, we are still young. We had the first dam built in 1980s, Kulekhani hydropower dam, the first phase with the 62 megawatt of electricity production capacity. So it has been many decades since then, but we don't have the second dam. Of course, Kulekhani 2 and 3 are there. We forget with that. They don't have the large storage. They are just the cascading or utilizing the water of the terrace for generating electricity, not exactly the second dam exists there. So why we don't have the dam for a long period is a big question to ourselves, whether we are reluctant to go for a dam, or we don't have technical capacity, or our geology doesn't allow for that. There could be three potential questions for that one. Is I leave up to you to discuss, identify the ways, and also continue discussing in GeoMandu, because we need to go for more power production without jeopardizing our environmental flora, fauna, and environmental resources. We need to find a trade-off. So how should we move forward? That's the big questions, and we all need to brainstorm together. I will keep an open question to you. Third thing is about in the recent decades and recent years, we are facing a lot of water-induced disasters. For example, Thame flood in August 2024. I think BGC team are going to explore that. September 2024, extreme rainfall and associated flood, landslide, and a combination of multiple hazards together, where even in Kathmandu we had to face a lot of losses and damages. And more than 25 stations in Nepal have received a record-breaking rainfall since Nepal started to record its rainfalls. So it means that the recent disaster events induced by water, and also it is compounding to other disasters like landslides and others, has been increasing over the years. It has becoming more costlier, more intense, and it is questioning to ourselves, we as experts, that you need to think different way when you're designing your water infrastructure. This is an alert to us. So in this context, there are increasing risks, and risks also being addressed even by shifting the headworks of the water infrastructures. We have experienced the very bad experience in June and August 2021 about Melamsi debris flow, right? So headwork area was intensely damaged. There were, I think, 60-70 billions of total Nepali rupees has been spent in the Melamsi water infrastructure project, including tunnel and downstream development and others. About nearly 1-2 billion rupees was damaged in the headwork area. The large section of that entire project was still intact. It was usable. And there was an option discussed initially about how about shifting the headworks upstream, about a kilometer upstream in the Sartathal area. Finally, after a series of discussion and the recommendation from the consultant, Nepal government decided to shift the headworks of the Melamsi about a kilometer upstream. I think they have started the process of tendering out and selecting the detailed design consultant and so on. It means the risk is intensified in a way that it is challenging to our earlier knowledge that whatever we are thinking right at that particular point of time is no more right at this moment. It doesn't mean that that time the expert did the bad thing. I don't think so. Because they also did a rigorous analysis, assessment, and with the multiple peer review process, it was decided that's an appropriate location. But after passing of several decades, it has been now concluded that there is a better option than that, and we need to shift it. So it means that risk is posing in a way that we have to rethink the way we build our infrastructure. We have to rethink the location of the infrastructure. It means we are we are challenging more by natural disasters or the increased risk. So this is the context we are operating. Then how we are responding in that? In many instances, to my knowledge, we are assessing risks for the single hazard, either for flood or landslide. But we haven't started it. Since, after Melamchi, a lot of discussion has been in terms of consideration of multiple hazard. But in terms of utilizing in designing water infrastructure, I think we are yet to move many miles forward. NDRRMA has developed some guideline for multi-hazard risk assessment, but now I think gradually it will start in translating into designing water infrastructure. So means the way we are practicing the risk assessment need to shift, and already some guidelines have been built for shifting in that way. So it means there is no single hazard. We need to consider multiple hazards. They interact each other. There are compounding and cascading effects and impacts. So it means that our infrastructure building process will be costlier, but it is expected to provide more safety to our infrastructure. So this is the direction I think we need to move forward, and we have started a lot of intense discussion in academic and professional platforms in those areas. So when concluding all the things together, in geohazard or all kind of hazard or risks to the water infrastructure, a lot of uncertainties exist. Even if we have, our knowledge has been strengthened compared to last 3-4 decades, it will continue to strengthen. Even if we have a lot of knowledges, skills, tools, and technologies, but still there exists a lot of uncertainties. It means single mind or a small team is not enough to make a decision. So we need to establish peer review process of our design or assessing risk for our water infrastructures. Many multi-billion dollar projects or maybe large scale projects practice that, but many medium-sized projects still doesn't go for that in consideration of the cost required. Because investment in risk assessment, investment in minimizing the risk, investment in peer review process is not really a cost. It is an investment. It gives a multiplier effect in terms of return. So we need to practice the peer review process for designing water infrastructure. We need to get prepared for more increased risks in the future. Therefore, consideration for multiple hazard, this cascading compounding effect, and the practice of consideration of clear water flood for designing infrastructure should be replaced with the consideration of the sediment-laden water for estimating flood risk. Or it means the kind of debris flow consideration, because many water infrastructures in our river systems, from now onwards, we have already experienced, from now onwards, it is very likely or highly likely that they are exposed to the sediment-laden water or debris flows, or maybe even with the boulders. So we need to kind of consider those things in designing water infrastructures, especially for flood or enhancing their resiliency. Therefore, maybe 100-year return period flood in consideration of the clear water maybe more than 100 years in consideration of the debris flows. Therefore, a lot of uncertainty exists, a lot of new risks exist, a lot of unknowns are exposed to our water infrastructure in futures. Therefore, we all need to be more we need to be more smarter than we were before. We need to consider more uncertainties in our analysis process, and we all need to put our efforts together, minds together, tools, technology, and learning process together, and strengthen the learning from our earlier failures together, so that we can build more resilient water infrastructure in our Himalayan river system. With this, I conclude my remarks. Thank you so much.